If you've played video games for a while, it's likely that you've run into a game called Snake. One version of this game is actually called Slither.io, and it's online. And if you play online games, I'm sure you've run into this game. We are going to do the original version of this game, and we're going to do it using turtle graphics in Python. So this is part one, and if you'd like to, please follow along. I think the best way to use this tutorial is going to be if you open your own project in Replit and try to do what I'm doing, and then add on your own customizations as we go. Okay, the first thing that you will need to do is to open a project in Replit, a new project. I have a video on this, which you should seek out on the website or on my YouTube channel if you haven't seen it. But we are starting from already having a Python with Turtles project, and I'm going to call this project Snake Game. We'll just call it Snake Game, all one word. Okay. Snake Game tutorial. That's actually better. Okay. So here I have my Snake Game tutorial in Replit. And the first thing I'm going to do, because this is a turtle graphics program, is I'm going to import the turtle library. Okay. And just to show it's working, I'm going to send a turtle command, turtle.forward 100. Okay, there it goes. All right, in this program, we're going to do something that we haven't done in my class before, which is to access the Turtle Systems screen and set some of the features of the screen in order to customize our game and make it look a little bit more interesting. So we do that by asking the turtle library to give us the screen. So we say get screen. Okay, but we can't just call get screen. We have to store the screen in a variable. So we're storing a reference to the screen in the variable so that we can send the screen commands in the same way we send the turtle commands. So we send the turtle commands by using this dot notation. Turtle.forward means send the forward command to the turtle. So once we have a reference to the screen, we can send the screen commands. And one thing I'm going to recommend to you is that you follow along with this video, stop the video or rewind the video anytime you need to hear me say something again. Also stop the video if you're trying to follow along and you would like to type some code into your Replit project to catch up with me. Okay, definitely pausing a video is one of the benefits of having a video. So what kind of command can we send the screen? Well, actually, if we go to the docs at python.org, you can look at all the turtle graphics commands, including the screen commands. You can find this page by searching for Python turtle documentation on Google. And if we look, you can see that screen appears lots of times on this page. And the example they start with when they show how to get the screen and what to do with it is this background color. They set the background color. So we are going to also set the background color, except we called our screen variable something different. We called it the screen, so we have to make sure that matches. So the screen.bg color, and instead of pink, I'm going to use honeydew. Now, if you're curious about the different names of the colors that are in Python, you can search Google for the letters TK together and color names, and you'll get a bunch of choices like, so this is what will come up if you search for TK colors or TK color names. There is a colors manual page for the library called TK, and this will show you the built-in colors that Python can use. Now, some of these colors that have numbers associated with them haven't worked for me, but nearly all of the other ones have. So if you're looking for interesting colors, you can try this list out. All right, so that's where I found honeydew. So I'm going to run this, And now the background color is honeydew. And so that gave me a little bit of customization, and it's going to help this thing feel more like a game. So now that we've gotten this far, I want to talk about the three main ideas of this introductory video. The three ideas I want to cover are the idea of a game element that has behaviors. I also want to cover the game idea of a gaming loop. And I also want to show you how to use keyboard control in your game. Okay, so the first thing is a behavior. What's a behavior? So if we treat the turtle like an on-screen character or something, then I would say that a behavior is some activity or some action that this on-screen character is performing during a game. For instance, let's say we give it let's say we create a loop. We're going to create a for loop for I in range 0 to 100. We're going to just do something repeatedly. So we're going to send the turtle dot forward. We're going to send it 10. Actually, let's go 1,000. Let's do two things. We're going to say turtle.forward 10, and then we're also going to go turtle.right, which turns the turtle a little bit, and we're going to turn it to the right 5 degrees. Okay, so if I run this now, then I get a behavior. This turtle is turning to the right and moving forward 5 degrees, and it's just going to continue to do that until the loop runs out. I'm going to call that a behavior. If I change this to turtle.left, I'm going to stop this and run it in turtle.left, here's a different behavior. This is the turtle turning left and moving in a circle to the left. Okay, so if we have something that we treat like an on-screen character, we can give it different behaviors, and these behaviors can use simple commands to set them up, but they make it look like the object on the screen is doing something intelligent, or at least that we recognize. This thing moving in a circle is how we describe this behavior. Moving in a circle by turning to the left. We can move it to the circle, turning to the left differently. It doesn't have to be one way. It can be, we can move in a tighter circle if we have a larger value for our turn, for the degrees of our turn. Okay. So once we have a behavior, what I'm going to do is I'm going to say that I can break a behavior down into steps. And that's what I did in this loop. So in one step, so think of a step maybe as being the tick of a clock. You know, if you can hear a clock ticking. So every tick of the clock, let's say this turtle is going to be engaging in one step of this behavior, and that step is going to be to do these two things. So I want to store this behavior in a place where I can use it later. So I'm going to define a function. I'm going to call this circle tight circle left. And whenever I do the tight circle left behavior, or wherever the clock ticks and I want to engage in a tight circle left behavior, I'm going to call tight circle left. How does that look? So I'm going to bring my for loop back again for I in range 0 to 1,000. So it goes for a while. And I'm going to call tight circle left. And now when I run it, it's the same thing I had before, but now the behavior is stored in a function, so I can see it. And I can do fancy things like I could change the amount that it circles and I can parameterize it. So I could say, angle. I could put angle in these parentheses so that I could choose when I engage in the behavior how much to circle. But right now I'm going to keep this simple, and each behavior I have is not going to be parameterized. Each behavior is going to be very simple, just a couple of lines. So if I have once I have a tight circle left, I can make a tight circle right. And this is what will be, the choice between circling left and circling right now is just something that I can do, by changing the code. But we'd like to get to a point where the behavior can change on something that is not me changing the code. And that way, you actually have a screen character that changes behavior based on something that the user does. Okay. So the second concept that I talked about was a game loop. So a game loop in a gaming program is the loop that is always running in the background that runs something like a clock. I mentioned clock ticks before. In almost every game, a clock is running, and it's kind of like the clock of the reality of that game. As that clock is ticking, every tick, something happens. Think of a very big multiplayer online game that has non-player characters in it, or any offline game that you might have played. As the clock is ticking, the game code checks with all of the non-player characters. Like you may have an enemy that's out there that's controlled by the game's AI. Every tick of the clock, the program is going to ask that game character to check its surroundings, to do several things, to engage in behaviors that are part of that game. We can do the same thing on a smaller scale in our game, and that's what we're trying to work towards by creating these behaviors. But now we also need the clock, the same kind of clock that a big game has. That's what this for loop is doing right now. But this clock has a definite end. Time runs out in a certain, after a certain amount of ticks of this clock. And we can see if we make the large number, this number smaller, that we will get there much sooner. This thing will only run, 100 times, and then the game is over. We exit. So instead of having this run finish at a set amount of time, I'm going to change this for loop to a while loop. I'm going to say while, and then I'm going to say not done, tight circle right. And before I go into the loop, I'm going to create a variable called done, and I'm going to say false. So done is false. We are not done. So while we're not done, keep repeating this behavior. This is kind of what a game loop looks like. The game loop is going to run forever until we decide that the game is over. And some event could, maybe trigger the game being over, something that the user does or some condition that happens within the game. We'll get to an event that ends the game in a little bit. But now it's important for you to see that you need to have something that runs the clock, and you need to have that thing running constantly in the background until something causes it to stop. And then in that loop, the behaviors are also going on. So this is a very simple game because there's only one character, but something that you might see in a more complex game would be during the gaming loop, you might see behaviors for lots of different characters going on at the same time. Just as an example of that, what I did here was I quickly made some changes where I created two turtles, T1 and T2, and I changed T2 to red so that you could see it. And then what I did was I changed these two behaviors so that I have to pass the turtle in. The turtle that's going to adopt that behavior is getting passed in. And now in my game loop, what I've done is I've let each of these turtles update their behavior. Now they can't change their behavior. They each have their own behavior. So each time I'm telling T1 that it's going to do a tight circle right, and T2 it's going to do a tight circle left. And I just wanted to show you that this is how, in a gaming loop, you can do you can have multiple characters doing different things at the same time. And so you'd have a long list of every character in this game doing some behavior, and that behavior may change over time in order for the game to work. Okay, I've removed those changes, so now we're back to the one simple turtle and its behavior. And this turtle right now is going to circle forever. So what if we wanted the circle's behavior to change, or I'm sorry, what if we want the turtle's behavior to change based on user interaction? So we would need the user to be able to create an event of some kind that would change the turtle's behavior, or that would allow us to kind of listen for that event, or listen to what the user's doing, and then change the turtle's behavior. Okay, so this, in order to do this, we have to get the screen, and this is one of the reasons why we got the screen. We have to get the screen to listen to some resource, and that resource or controller is going to be the keyboard. And actually, the screen has some built-in functions that allow you to listen to the keyboard. And generally in programming, we call these keyboard bindings. What that means is that we bind or attach the keyboard to certain events that are going to happen. So here's the way keyboard bindings work. You have to tell the screen to listen, and it will listen to the keyboard. And then you have to just tell it what keys to listen to specifically. And this is what a command that sets that up looks like. You say the screen.onKey, and then you have a defined function that is going to be run when a certain key is hit. So this key is the L key. And when I hit an L, I want to call a function that is called goLeft. And this function is just going to be used to tell the system that I want my actor, my little turtle, to engage in the goLeft behavior in the loop. When the R is hit, I want it to call a function that is going to tell my program that the character should start engaging in a goRight behavior. All right. Okay, what I've done now is, after creating the keyboard bindings setup, in order to have these keys trigger some function, I have to define those functions. So I created the goLeft and goRight functions. And in these functions, what I've done is set a variable that is attached to the turtle called behave. Maybe I should have called it behave with a name. Let's call it behave. So let's set behave. Okay. But also in these functions, I've put a test print statement. You can always put print statements in your functions to see if it's working. And the question I have is, I want to make sure if I'm trigger these events, is it really calling these functions? So while the turtle is going around in circles and in circles and circles, the clock is going. I want to see if, when I trigger goLeft and goRight, if it's actually if the message is actually getting to these functions. So if I hit L, I should see it should call goLeft, and then goLeft should set this variable, but also print going left. And if I hit the R, it should call this function, set this variable, and print out to the screen going right. So I'm going to try hitting L to see if that works. And there it is. So I know that function is getting called now every time I hit L. And I don't know if you can hear me hitting it. It says going left. And if I hit the R, it says going right. So I'm going to add one more just to see. On key. I'm going to call it stop. So the last behavior is going to be stop, and it's going to work when I hit the S key. And so I need to create another function to kick off this behavior. And so I'm going to define stop. I'm going to actually call it stop it. And I guess we should follow through on the practice we've had here. So I'm going to say stop underscore it. And when stop it is called, I'm actually going to set the value of done to true. Done equals true. Oops. So done will no longer be false. All right, I'm going to stop my program. I'm going to clear the screen, and I'm going to run it. So there's my program, and I'm going to hit L, and I see it goes to the going left, and hit R, and it goes into going right. And when I hit S, looks like S is not working. So I did something wrong. Oh, there's a syntax error. That's why. Okay, so stop, run. Okay, I had to make some quick modifications to this to get it to work. All right, so let me explain what I'm doing here, what I added. So I added the, I actually changed the name of this function to so done because I think that's a little bit more fun. Anyway, and I'm in this behavior, I'm setting a variable called turtle.done to true. And I'm also printing the test message stopping. So I made a change in my gaming loop. Instead of using the variable done, I used turtle.done. So you can add a variable to the turtle, and I added a variable called done to the turtle, and I set that to false. So instead of done.false, I have turtle.done equals false. And so while not turtle.done, it's going to do this circle right. So if I change the value of turtle.done to true, then the opposite of true is false. And so this will end as soon as turtle.done becomes true, because not turtle.done will be false. So let's test this out. So if we go, whoops. So if we hit the R, it says we're going right, but of course we were going right already. L doesn't change the behavior, but prints our test message. And then I changed the key that it listens to X to end the program. So X ends the program. It says stopping. Down here it says done. And the turtle stops going around in circles. So the only thing that we need to fix now is, even though we know that the commands to change the behaviors are working, we haven't actually changed the behaviors. So we've set variables to keep track of the behaviors being changed, but in our gaming loop, we're just always doing the same thing. We're doing a tight right circle. So let's just put an if statement here so that we have we check what the turtle should do. So if in this loop turtle dot behave is equal to right, then we are going to tight circle right. And then else, we're just going to keep this simple right now. So anything else that value is, we're going to tight circle left. And then one additional thing we need to do is we need to make sure that that turtle.behave has a value before we check it. So at the beginning of our gaming loop, we're going to say turtle turtle.behave, we need to make sure that turtle.behave has a value, so we're going to set it equal to right. So we're going to start out, well, let's set it equal to left. So it starts out circling left. All right, let's test our program now. All right, so it starts out, good sign, it starts out going left. So what if I hit R? Let's see if it changes its behavior. So it changed its behavior. Now it's going right. So then I'm going to hit left. Now it's going left, right. So now every time I hit the key, the turtle changes its behavior. And we have actually two distinct behaviors that we can trigger with the keyboard that will run in our gaming loop until we hit X and then we exit the program. So if you've followed along, here's the code for this point in the program. What I would like you to do at this point is modify this program so that instead of having two behaviors, you have three distinct behaviors. I would say change the two behaviors that I have here to be different than these and create a wholly original to you third behavior to add to this program that is triggered by a different key being hit. And of course, play around with any of the other customizations of this program and see what you can come up with.